Good morning. My name is Dr. Scott Jackson, and I'm here with my cat. This is Troy, nice white cat. Hi, how you doing? So he's going to help me give the presentation today. All right. So I'm going to talk a little bit about myself, and hopefully not lose my earphones and everything else. Yeah, he likes me. Of course, I'm the only one that feeds him. Might have something to do with it. Come on. So a little bit about myself. So I've only been with Villanova for about 4 or 5 years. And I actually came from DuPont. I was a senior technical fellow in the research department. About 4 years ago, DuPont downsized, got rid of the central research, and I found myself, along with 3,000 other people, without a job, which is just fine because I was thinking about what was my next step in my career. And it was logical that I found Villanova, and actually it's a great opportunity for me to bring my industrial experiences to Villanova in the classroom. So I've had 33 years of industrial experience, have lots of patents. Remarkably, I did manage to get some publications while in central research. The emphasis is usually generating patents and not necessarily presentations or publications, unless you're doing technical marketing, which is some of the aspects of my work was, in fact, technical marketing. And then I did get a couple of awards, which I'm very proud of. And perhaps what I'm most proud of is the fact that I'm an amateur astronomer. You can actually see over here on the side. I'm going to annotate this. Mount Cube Observatory right here. So this is our 24-inch reflector, and then this is a small 4-inch refractor. And out here, which you don't see, is a new telescope that's going to be built this spring. So one of the largest on the East Coast of the United States. So long time avocation for me. I really enjoy astronomy, and I'll sometimes inject some of my experiences in astronomy into chemical engineering where appropriate. So I have lots of interests. It's basically in part because of my experiences in DuPont. For example, I have I'm very familiar with microbial process industrial applications and done work in coal to methane generation. More importantly, microbial enhanced oil recovery, which is sort of an oddball thing, but I wasn't a petroleum engineer for a while as a result of that program. And then a number of other things in here. A lot of this I have managed to pick out examples that I can inject into my courses in heat transfer, engineering economics, senior lab, for example. In senior lab, we actually, I pulled out of my lab at DuPont before they threw it away, what's called a CAR extraction column, liquid extraction column. And we actually have that set up as in our senior lab, and the seniors actually run a real extraction column, and they have to measure something called height equivalent through a theoretical stage, and then they have to actually design a commercial column. It's all pretty cool. It really very much based on my industrial experiences. So I see my cat has decided that not to help me anymore, so he's wandering around trying to figure out where he can find some more food. So what I really wanted to talk to you about today is my experiences with Senior Project Studio, which is pretty cool. So here, Senior Project Studio is an opportunity for seniors to attack, I'll call it, industrial problems. And it's pretty amazing that the students really come up with very imaginative solutions. You know, there's a little bit of an induction period where they try to understand, grapple with what the concepts are, but it's really an enjoyable experience watching these students get it. They suddenly realize they have have some ideas about things and go on off and develop things that which really relies on their own knowledge. There's really two cases of Senior Project Studio. One is where they actually rely on knowledge and concepts that they've garnered from their actual classwork. And that's usually very much related to chemical engineering. And for example, there's a sort of a plug flow reactor that one group's working on where they actually have internal agitation in it. And this may all sound weird to you, but it's very much a chemical engineering problem. The problem that I'll describe today is something that really relies much deeper in that the students have to work on a project, they may not have been introduced in a classroom, but they have to apply their problem-solving skills. And in many ways, it reflects my own career in that I was very often given many problems that had nothing to do with chemical engineering, but had everything to do with my ability to analyze things and peel away an onion to try and get to a problem and a solution. Very challenging, but still it's really very exciting to learn things new, and you're constantly learning things in this case. So there's a couple pictures down here of Villanova students doing research. Sort of thought it was pretty cool. So let's talk specifically about the one project that I've been involved in, and that's ball chain coating failure. So there's a company, it's up in New York City, called Ball Chain. At one point in time, they're the almost sole manufacturer of ball chain. So ball chains basically are things that go around, and let me turn on the annotation again. Oh, we'll do this. So this is the ball chain here, and this actually is a roller shade. So this is a shade that's going down across the window, and you manipulate the shade by moving this chain. So you move the chain, pull it down on one side, it goes up in the other, and it rolls down, and the shade goes down. Pretty simple. Ball chain, www.ballchain.com, actually had the corner of the market. They basically originally were making these ball chains for GIs during World War II for their ID bracelets. Okay, they still do that kind of thing, but one of the big part of their markets is in fact in this ball chain for roller shade applications. Well, these ball chains are actually coated with an acrylic coating, and that's fine. So that's where it would stop if there was any issues. But there is an issue, and the issue basically is the customers are seeing discoloration of the ball chain. So what you see over here is an apparatus that two students, Alex and Justin, put together, and you can see that this is actually a ball chain mechanism here. Let me. I wonder if that's. No, it's not. So you can see there's actually this is one of the ball chain mechanisms. Here's another one. What you don't see is one is actually driven by a motor on the backside. And so the students can actually adjust the speed and actually adjust the torque as well. And if you look at the ball chain, this has been worn in for about an hour and a half. You can see these markings on the balls. And this is actually the coating that has failed. So the coatings come off. You can actually, down at the bottom here, you can't see it here, but there's actually chips of paint that have fallen out. And this has been pointed out by the customers. And so it's a big concern. So it's not a huge issue because most of the ball chain is not necessarily coated this way, but there is a significant segment of the market that would like this coloration on the ball chain. And somehow we've been asked to address this. Okay? So what they did, this is Alex and Justin, is they ran this ProDraw that they developed on this test jig that they developed, and they actually came up with coating loss. So this is a plot of, let me turn on my animate. This is a coating loss here. This is a change in coating versus time. You can see they ran it out to an hour and a half. And after each 30-minute interval, they actually measure the weight loss. So it's quantitative. So now they've taken what would be a qualitative testing method and actually made it quantitative. And there was a new coating technology that we were asked to look at. And sure enough, this new coating technology actually shows a much lower coating loss than the old coating technology. So this is really great news. Unfortunately, then the coronavirus came along and put a stop to it, because our next step, and what we're planning on doing is picking this up with a new set of students, is we're going to actually do some analytical methods, some scanning electron microscopy, some energy dispersive analysis X-rays, and also some possibly nano indentation and some more optical microscopy to try to understand whether it's an adhesive or cohesive failure the coating. So that sounds really sexy and technically difficult, but the fact of the matter is it's a great learning opportunity. It's not necessarily something to learn in chemical engineering. It's more a aware kind of thing. But the actual chemistry about these acrylic films and then this new film, which I'm not telling you what it is about, because it's novel, it's a proprietary. It actually deals with chemistry, which is something that, in fact, the chemical engineers do have to know about. So I hope you enjoyed this little thing. You know, you can always find my email on the on our website if you have any questions. And I'll have Troy here say goodbye, and have a good day. Okay, bye-bye.